Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. Today in this video we're going to talk about application with polynomials, and what I mean by that is just taking the skills that we learned of polynomials and apply them to shapes. So we're going to start here. My instructions say find the area of the shaded region. So you'll see I've got a large box, and then within that I have a smaller box, and then I have shaded, and I've used the color blue. So we need to know the area of all the blue. An important formula we need to know here, I do expect students to know this coming into Math 1, that the area of a square is length times width. So that's an important formula we use a lot. We need to know that one. So how we solve this is first we need to find the area of the larger rectangle. So I can do that if I know rectangle area is length times width. I know my length, it's 5x plus 8, and my width is 6x plus 2. So I'm going to mark this as the larger, or the large rectangle. Okay, so I need to multiply my length times my width. So 5x plus 8 times 6x plus 2. Now hopefully you recognize that this is a binomial being multiplied by a binomial. So we talked about that in one of my previous videos, that what we do in that case is we FOIL. If you need a little review on foiling, definitely go back and check that video out. So when we FOIL, I multiply my first two terms. 5x times 6x is 30x squared. Now I multiply my two outer terms. 5x times 2 would be positive 10x. Now my inner terms, so 8 times 6x would be positive 48x. And now my last terms, so 8 times positive 2 would be positive 16. Okay, so I need to take one more step to combine like terms because I see I have some like terms right there. So my 30x squared would stay the same. 10x plus 48x is positive 58x plus 16. So that is my area of the large rectangle. Now I need to find my area of this smaller rectangle, but I'm going to do the same process. So I'm going to mark it as the small, so I can keep these straight. So this one is the smaller. So I need to do my length times my width again. So 5x times x plus 6. And in this case, I've got a monomial and a binomial, so all I need to do is distribute that 5x in and multiply it by each term. So 5x times x is 5x squared, and 5x times 6 would be positive 30x. So my last step is now, if I know the large area, and I know the small area, I can subtract these and it will give me the area of all of the blue. So the way I set this up is 30x squared plus 58x plus 16. So that's my first polynomial, or it's a trinomial, minus my second area. So 5x squared plus 30x. Now, if you remember from my video on adding and subtracting polynomials, there's an understood one there and there that we need to distribute in. We talked about how anything times positive 1 is just the original number, so I can just go ahead and write that. So I'm just multiplying this 1 times each term. I'm getting that. And now I need to distribute this negative 1, and I have to be a little more careful here. So negative 1 times 5x squared is negative 5x squared. and negative 1 times 30x will now be negative 30x. My last step here is to combine any like terms I have, and as I'm combining like terms, I'm going to make sure that I write my answer in standard form. So 30x squared minus 5x squared, I have those two like terms. So that would be positive 25x squared. And my next two like terms would be just my x's. So I've got this positive 58x and this negative 30x. So that would end up with positive 28x. And lastly, I have this plus 16. Nothing to combine there. So this is my final answer. This is my area of my shaded region of the whole blue. In this example number 2, my instructions also say find the area of the shaded region. So I have a large triangle, a rectangle within it, and I need to know the area of all of the blue. So the two important formulas we need for this problem is the area of a triangle is 1/2 base times height. 1/2 times the base times the height. And the area for a rectangle or a square is length times width. So the first thing that I want to find out is the area of the whole triangle. So following my formula, 1/2 base, which it says is 2x plus 6 times my height, which is x plus 8. What I tell students is usually just kind of leave this 1/2 on the side. Let's go ahead and FOIL these two binomials, and then we'll take half of it. I think that's the easiest way to do this. We're going to FOIL, so I need to do my first. 2x times x is 2x squared. My outer, positive 16x. My inner, positive 6x. And my last, positive 48. So I'm going to go ahead and combine my like terms. So, and as in Math 1, we're always going to have those two center terms. So 2x squared, 16 plus 6 is positive 22x plus 48. Now, I can't forget about that 1/2, so I need to bring that down. You can either have your 1/2 outside of these parentheses and distribute it in. That's one way to do it. That's the same thing as just dividing by 2. I think this looks a little better than having a fraction on the outside of the parentheses. So let's go ahead and just divide all my whole numbers by 2. So 2 divided by 2 is just 1. So it's just x squared. 22x divided by 2 is positive 11x. Positive 48 divided by 2 is positive 24. So I now have my area of my triangle. Now I need to find my area of my rectangle. So area of a rectangle is length times width. So I have my length and my width. X times x plus 1. I've got a monomial times a binomial, so I need to go ahead and distribute that in. X times x is x squared. X times positive 1 is just positive 1x, or just x. And there's my area of my rectangle. So I now need to take the larger area, subtract the smaller area, and that will tell me my total area of the blue. So I'm going to write this as x squared plus 11x plus 24 minus x squared plus x. And I had a student ask me today, do I have to put the parentheses around these? I say yes, because you have this negative right here. If it was a positive, no, you don't have to put the parentheses. But because this is a negative, it's important for students to know that that's a 1 outside, so we've got to distribute that -1. We covered that in my video on adding and subtracting polynomials. So this will stay the same because it's got a +1 outside. +1 times anything is just the original number. -1 times x squared is -x squared. -1 times x is -x. I need to combine my like terms. So I've got x squared minus x squared. So what happens is those actually cancel out because that would be 0. So I can just cancel those out. 11x minus x would be 10x. And lastly, my constant plus 24. So this is my area of the shaded blue region. In this third example, my instructions are still the same. Find the area of the shaded region. Just a little more complex, but again, I just want to know what is the area of all the blue. So my first step is to find the area of this larger rectangle that's happening here. And I see that my length is 5x minus 12 and my width is 3x. So let's go ahead and note that we're talking about the large rectangle. And we'll find that area. So I need to take, now I didn't write it on this sheet, but I expect that we know by now, area of a rectangle is length times width. So 3x times 5x minus 12. I've got a monomial being multiplied by a binomial, so that means I distribute in. So 3x times 5x is 15x squared. And 3x times -12 is -36x. I cannot combine these because remember when we're adding or subtracting, my variable and exponent have to be exactly the same. So these are not like terms. All right, so now I want to find one of these littler rectangles. So I know my measurements of 1. In this video, we are going to assume that this is drawn to scale and that each of these is the exact same length. In order to find the area of this smaller rectangle, I'm going to do also my length times my width. So x times x plus 2. Again, I have a monomial being multiplied by a binomial, so I need to distribute this in. X times x is x squared. X times +2 is +2x. So I need to take one more step here because before I start subtracting, I've got to remember that there's not only one of these little white boxes, there's 1, 2, 3, 4 of them. So I need to take this and multiply it by 4. Now again, I have a monomial being multiplied by a binomial, so I just distribute that 4 in. So 4 times x squared is 4x squared, and 4 times +2x is +8x. So now I have my area of my large rectangle and my area of each of the small rectangles together, and I can subtract them to find the blue area. So I'm going to set that up. We've got 15x squared minus 36x, subtracting 4x squared plus 8x. Remember, I've got that -1 and that +1. +1 distributed in will just give me the same answer. And -1 distributed in will give me a -4x squared minus 8x. Now I just need to combine my like terms. So I've got +15x squared and -4x squared. So 15 minus 4 would give me 11x squared. And then I've got -36x and -8x. So -36 minus 8 would give me -44x. So in this fourth example, my instructions this time are just find the area. You'll notice there is no shaded region here. It just wants to know the area of this whole shape. And this shape is kind of awkward. It's got a boxy shape to it, but there's nothing specifically that we would call that in Math 1. So what I need to do, there's a couple ways we could go about this, but how I'm going to do it is split this shape up into a more reasonable shape. So I notice that this is a square, so I'm going to go ahead and just separate that off. I can find the area of that square. Same thing over here. I can actually find the area of this rectangle, so I'm going to box that off. And I can find, I've now created a large rectangle on the bottom, and I can find the area of that as well. Once I get those three areas, so the area of here, here, and here, I can add them all together to give me my total area. So let's start with this small one right here. I'm just going to call it my first square slash rectangle. So I see that from here to here is x, and from here to here is x. So x times x, or we would write it like that in parentheses, gives me x squared. Now, to find my area of this second rectangle, I would take my length, 2x, and multiply it by my width. Now, if I know this over here, assuming these two have the same height, I can make the jump that if this is x, this is also x. So we can go ahead and make that jump that if this is x, this is also x. So my width times my length here would be x times 2x. X times 2x is 2x squared. All right, so now I need to find my area of my third rectangle, which is this large one on the bottom. So I've got to do some estimation here. If I know this entire side is 2x, and again, this doesn't quite look like half, but we're assuming that this is drawn to scale, so I can go ahead and make the jump that if the whole thing is 2x, then from here to here is just x. Now, I need to know the length, so I need to know the whole bottom, how long it is. Well, and if I know from here to here is x, I can assume that from here to here is x. And same thing here, if I know from here to here is x, then I can assume that from here to here is also x. And if I know from here to here is 2x, I can assume that from here to here is 2x. So adding these all together, x plus 2x would give me 4x for the entire bottom. So I'm going to multiply my width of x times my length of 4x. And x times 4x is 4x squared. So now what I want to do is I want to add each of these together. I want to combine like terms where I can. These are all like terms actually because they're all x squared. So I can combine all of them. So I've got 1, understood 1 there, plus 2, that would give me 3, and 3 plus 4 would give me 7, x squared. Remember when we add like terms, the term and the variable stay the exact same. So 7x squared is our area of the entire shape. This has been Miss Smith's Math Tutorials.